Okay, Advanced Math Trig guys, Mod 7. It is Wednesday, April the 8th, 2020. I want you to just put at the top of your notes today the word application problem or application problems. I am going to give you a break today. All your job today is to do this one problem with me. It is a word problem, so you're going to write it down real quick here. I'll hold it here and give you a chance to copy it down. From a certain distance, comma, the angle of elevation to the top of a building is 17 degrees. At a point 50 feet closer to the building, the angle of elevation is 31 degrees. They want to know how tall is the building. So again, this is an application problem and is the perfect problem. It should look or sound familiar because it's identical to one that we had done, probably about 4 weeks ago when we were doing SOHCAHTOA and trigonometry and the study of right triangles. But there's going to be a much quicker way to do it now that we know the law of sines and the law of cosines. So again, from a certain distance, the angle of elevation to the top of a building is 17 degrees. At a point 50 feet closer to the building, the angle of elevation is 31 degrees. They simply want to know how tall is the building. Okay? Well, here we go. To do this problem, let me move the camera just a hair so you can see my writing better. All right, let's examine this. From a certain distance, the angle of elevation to the top of a building is 17 degrees. Here I am from some distance away from the building. Okay, that's irrelevant right now. There I am, and it says the angle of elevation to the top of a building is 17 degrees. So I'm going to go along the ground, draw a building. Let's say that's our building. And the angle of elevation looking to the top of it is 17 degrees, as it says. So far, so good. At a point 50 feet closer to the building. Oh, so now I'm going to start where I was at, and I'm going to move to a point that's 50 feet closer to the building. So draw your little picture here and go 50 feet to the right. Now from that point, of course, if I look at the top of the building, aren't I going to be looking upward at a steeper angle than I was when I started? So it does say the angle of elevation is now 31 degrees. So looking up to the top of the building from there, I've got a 31 degree angle of elevation. And they want to know how tall is the building. So the height of the building, this height over here, you can see me highlighting it right now. This height, the height of the building is our unknown value. So we'll call that X, the value that we're seeking. Okay, guys, if you remember back when we started right triangles and we did some applications before, this is a problem where I would call the bottom of that little triangle Y. Now don't do that. And we would end up going to this 31 degree angle. Now remember this? We would do opposite over adjacent, which is what? Tangent. And we would write the tan of 31 degrees equals X over Y. Then we would go to the 17 degree angle, and the opposite side would still be X, but the adjacent would be 50 plus Y, and we wrote the tan of 17 equals X over 50 plus Y. And then we really had to do a lot of work algebraically to manipulate those two equations, eventually solve for Y first, and then use that to plug in and solve for X after doing some more work. So the point is, this is a word problem that we've already done or tried, at least one similar to this, and we had to use SOHCAHTOA, and algebraically it became very messy. All right, well, let's look and think now. Now that we've learned the law of sines and the law of cosines, does everybody agree? Watch this. This is a straight line, right? So this 31-degree angle and the angle right beside him are certainly called what? A linear pair. It's a pair of angles right beside each other, making a straight line. And a straight line always equals what? 180. So if this angle's 31, the angle right beside it must be what? 149? Oh, that's right, because if that's 149 plus that's 31, that's a total of 180. All right. Now what can we do? Well, if that's 149 and that's 17, you agree if we add those two together, that'd be 166. And 180 minus 66 leaves us with 14 degrees right there. Oh my goodness. Well, let's think about this now. Again, they wanted me to figure out the height of this building. So I've got this side, which is X. This side, I don't know the size of it, do I? So I'm going to call that Y. But think about it. If you look at this obtuse triangle that we created, couldn't I now use the law of sines to figure out side Y? And once I get side Y, it'd be really easy to go back over and solve for X. Let's clarify what I just said. Looking at the obtuse triangle, this angle here is 14, isn't it? And the side that's across from him is 50. So if I use the law of sines that we learned about a couple of days ago, couldn't I take this side, which is 50, put it over top of the angle that's across from him and write the sine of 14 equals, now take this side, which is Y, and put him over top of the side that's across, or excuse me, the angle that's across from him, which would be the sine of 17. So cross multiplying, I've got Y sine 14 equals, cross multiply again, 50 sine 17. To get this Y all by itself, I can divide by the sine of 14. And I'm going to end up with, once I cross those out, all right, I guess I should have warned you, you need your calculator here. I'm going to push 50 sine 17. I'm hitting enter, and then divided by sine of 14, giving me 60.4. So if we just discovered that side Y is now 60.4, and we want to know the height of the building, couldn't we now go to this right triangle? Since this is a 31-degree reference angle in this corner, couldn't we use opposite over hypotenuse? And remember SOHCAHTOA, opposite over hypotenuse would be sine, correct? So I'm going to write the sine of 31 degrees equals opposite, which is X, over the hypotenuse, which is 60.4. He's understood to be over 1. So when I cross multiply, I get X equals 60.4 times the sine of 31. I'm going to push 60.4 sine 31 on my calculator, and X is 31.1. I'll be darned, and I found the other side of my, the height of the building would be 31.1 feet. Okay? The whole point is this. We spent 2 days trying to learn the law of sines, learn the law of cosines, And they're not just used in generic, here's a picture type problems. This is just one example of a word problem similar to one we've already done, where this type of calculation with the law of sines and cosines could actually come into play. Now this one, of course, we use the law of sines. I easily could come up with an example where we'd use the law of cosines instead to try to solve a missing piece that would help solve an application type word problem, okay? So that's it. We've done law of sines, we've done law of cosines. I've shown you how they can be used in a little bit more fancy application type problem. Something like that is something you'd be expected to possibly do in calculus next year if you're taking that. And with those two topics now being done and kind of wrapping them up with this problem here, again, you've been working hard. You did a great job. That's it for today. There's no homework assignment for this. I just wanted to utilize that to show you how law of sines and cosines can be used in word problems. We will start a brand new chapter tomorrow titled Conic Sections with circles, ellipses, hyperbolas, parabolas, things like that. So I will see you on Thursday. And then remember, there's no school Friday. It's Easter weekend. Friday is Good Friday. So, hey guys, no homework tonight, no assignment to do. I will see you tomorrow on Thursday, okay? Bye.